Buenos dias, amigos tensores. Good morning, tensor friends. A couple videos ago, we derived this expression for the generalized expression for the divergence of a vector field. It works in any coordinate systems. It's an invariant tensor equation. Got an interesting question about this. When we started this derivation, we started with this innocent-looking thing. The question is, why can't I just use this as an equation for the divergence? Well, you can. You can use it, but let's show you what it looks like in real life. Okay, so the divergence of a vector is equal to the covariant derivative of the vector components, all right? Now, we want to expand this into what it is, so we're taking the covariant derivative of vi, I is in the covariant position. So you start out by always taking the partial derivative of that component with respect to the coordinate. Here's the coordinate. Then it's a plus sign because this is contravariant, rather. And you Christoffel the symbol times a vector component. All right, so you see this I has to match that I, and this I has to match that I. Then you're left with nothing, so you have another summation index, a dummy index. So there are no free indexes in this expression. These are all summation indexes, and this is a double sum. Okay, what's that mean? Let's look at it in detail. Let's say we're in 3 dimensions, so we're going to have 1, 2, 3 as our coordinates. All right, so let's look at this thing. So we're summing this from I equals 1 to 3, and we're double summing this from I equal 1 to 3, and then from K equal 1 to 3. All right, so let's bust this out. All right, the first case is easy. It's just I is equal to 1, and then 2, and then 3. All right, now let's sum over I, this expression, right? So we got 1, 2, 3. Now we got to sum it over K. All right, here's the first thing we did. Now, so in the first case, K equal 1, 1, 1. The second case, K equal 2. The second case, K equal 3. So let's see if I got this right. I got 1, 2, 3, and then 1, 2, 3. Yeah, this is right. So that innocent looking equation gives you 12 things you have to find, and 9 Christoffel symbols you have to find. You can use it and it will work, but isn't it so much easier to use this, which is just going to give you a few terms? In 3 dimensions, this is only going to give you 3 terms. All right, so that's the difference. And in either case, you have to find the metric tensor, because that's what this is, right? This is the partial derivative of the metric tensor with respect to the coordinates. So in either case, you have to find the metric tensor, but this is much, much easier. Okay, I hope that answers the question. I'll see you later.